guys for tuning on the live stream. We have a very busy conf going on and I am absolutely knackered from boss to the sock, but we're going to do our best to give you about a 20-minute presentation. Hunting hard, failing fast and maintaining integrity. My name is McLaren. I'm a Splunk delivery consultant based out in Scotland in the UK. I work for a company called ECS. This is just the standard intro slide, lots of pretty pictures and certifications, but you're probably not very interested. So, who I work for, biggest delivery partner in the UK, probably also not that interested. So, that's what we're going to talk about. We're going to talk about the basics of the capability within a security operations center. We're going to talk a little bit about threat hunting and where that's moved to over the last few years. Balancing SOC risk, we'll kind of skip over that a little bit, just so you're not bored to death. We're going to look about using Splunk as an agile theme, and how it really does support a lot of this kind of agile hunting practices. The evolution of DevSecOps, I'm going to touch on briefly, and then we're going to move on to the result of a pilot and now thing we've implemented for one of our customers. So hopefully you can see that. These are the capabilities of a modern security operations center. The primary element being monitoring, detection, analysis, response. In the further end of the scale, we've then got hunting and automation and orchestration. So as you move from the left to right, you're kind of talking about maturity. So the most early security operations types of practices, they did basic monitoring. So that might be, has a user logged in 3 times incorrectly. We then moved into detection. This might be where we start correlating data across disparate log sources. Maybe we've got different correlation rules that alert into different ways. We then move across a bit more in analysis at this point. So this is where we're starting to maybe try and detect and find things that we don't know are there. So also known as detecting the unknown knowns or unknown unknowns in some cases. We have the response capability. So when you find something, there is an argument to be said that if you can't respond to it, why are you even detecting it? If you're implementing detective controls as simply an FYI but have no ability to respond, well, in many cases you're going to have a bad day. Then moving into the hunting and automation orchestration element. So hunting, looking for the unknown unknowns, trying to find things that might exist within your network, within your logs, that have been left by some form of an attacker or inside a threat. Moving into automation and orchestration, this is trying to reduce SOC fatigue. And when you work in a security operations center or a network operations center for that matter, you often suffer from a significant amount of false positives or notable events that simply don't mean anything to your business. And many legacy organizations simply haven't spent enough time understanding that problem and implemented solutions to it. And then finally, orchestration, that is the ability to take action either on behalf of a human or to take a human action in a very quick and easy way. So just to touch on threat hunting, this isn't going to cover the ins and outs, but what it will just mention is that there is a very well-established method for hunting. So this is looking for things within your environment that you don't know are there. So if you think about it in the way you would hunt in a more traditional sense, you're trying to find something in the forest. You might have an idea of what it might look like, you might have an idea of the kind of tracks it might leave, but you don't necessarily know exactly what it is until you find it. So that starts in the create and hypothesis area at the top. This is when you have a thought, a feeling, you've read some forms of tactics that you think, hello, how you doing? We're live streaming, but you're welcome to stay and watch as well.
Yeah. On the Slack channel.
Yeah, exactly. So at this point, so you've got an hypothesis. This means you have an understanding of the TTPs, the tactics that somebody might be trying to use, the tools they might be trying to use, or the procedures. You then investigate that. So this is where you look for signs of the use of those tools and procedures. You look for possibly, the remnants of executables left. You look for things executed in memory, maybe never written to disk. And this is where you then start to uncover the pattern. You uncover something that is occurring on your environment that leads you to believe that you are being compromised. Now that does not always happen. And this is really important to point out, that between create and investigate, your hunt can stop here when your investigation shows that there is nothing to find for and therefore your hypothesis is being voided. But if you do find something, you found a new pattern within techniques, tools, or procedures, You then are able to build this into your current analytics suite. So that means you add detective control, you're adding a capability to respond, and then your life cycle is complete and you move on and maybe you have another hypothesis. So just, if there's anything to take away from that, you come up with a hypothesis, you target something, you try and find it, and then you want to disrupt that attacker or stop them from disrupting you and disrupt them in the future. So the way that works within a modern security operations center, they might refer to that as adaptive threat hunting or agile threat hunting, is these things happen very quickly. This isn't a project, this isn't something that exists for weeks and weeks on end. This is something where you empower an analyst or an engineer to do some research, to try and find something new within your environment, and if you find it, fantastic, but you often won't, and the majority of hunting leads to absolutely nothing other than proving that your hypothesis was wrong. But that in itself is very valuable. So the 3 Rs on the left of the screen, that's just, again, really hammering down there. You have an hypothesis, you ideally discover a threat, and then you try and work out how you're going to respond as an organization. However, on the other side of that coin, you've got threat actors, i.e. the people trying to do something wrong. They are going to constantly try and alter their techniques, their tools, and their procedures, because they are very aware that you're trying to find them, you're trying to disrupt what they're doing. So, one of the things that, when I started my career, I worked in the Security Operations Center. I worked as a senior analyst, and one of the things that we were highly regulated. We worked for a bank. Now, the issues with that is that we were trying to very quickly modify what we were doing. We were trying to modify our rules. We were trying to tune things. At the time, we were using a different product to Splunk. We then moved into Splunk, and which made things a lot easier to change, a lot easier to migrate. But every time we made that change, that's actually introducing risk. And one example of this was we had a change record, so we'd done everything right, we had a full ServiceNow ticket, it had been approved, and the analysts took that and they said, cool, and they went and modified the wrong piece of logic. They changed the wrong search, they saved it, and they completed the change. Now, what that did was that reduced the bank's capability to detect a problem in a certain area, and it essentially switched it off because they increased the threshold from 10 to 100. Now, the bank didn't know that. The change record was legit. They just simply made a mistake, honest mistake. But what that did was introduce risk. It introduced risk into the organization, and therefore, that's a bad thing. So balancing that risk is something really important, and it's something that as we start to use technologies, especially like Splunk, becomes really important to balance empowering users to make change with what the business needs, which is assurances that those changes don't introduce further risk to their business. So this is then when the concept, and this is something that's kind of come out of software development originally in the DevOps space, and is now moving into something that's more relevant in security as well, as these worlds start to merge more and more, and that's DevSecOps. Again, I'm not going to do a deep dive on what this is, but simply to point out that one of the key elements of DevSecOps is this continual life cycle of experimentation, safe change, orchestrated throughout your entire system. And that's often referred to as kind of a development release pipeline or similar. Hey, so the key takeaway and delivery element around DevSecOps can be applied really well to the way we develop new use cases, rules, and Splunk. The reason for that is that Splunk already supports a huge amount of this by default. It's one of the reasons we chose it as a partner 6 years ago, and it's one of the reasons that I still love it today. So fundamentally, you've got SPL at the top, so you can change what you want to do at will. You empower your users. It's all very graphical. It's all very interactive. You don't need to be a kind of stereotypical nerd or geek to have and get on the command line. You can do a lot of things in the UI. This turns out to be really important when you're trying to encourage and enable users to make things themselves. And then on the bottom half, this turns out to be really important when you want to automate and when you want to orchestrate out change to the system. So plain text config sounds really simple, why wouldn't you? But many similar types of technology will have binary-based configuration or have it in a database. That's very hard to version control. It's almost impossible to roll out using tools like Ansible, Puppet, or Chef. And all of these things, therefore, inhibit change and inhibit experimentation. And then finally, an enumerated and documented API again, as it turned out, which we didn't know at the time when we experimented with this, again turned out to be really important. because there were things we needed to do with Splunk that Splunk didn't support natively, but the API did, so we just wrote it. So finally, this is what we came up with. So our project was to deploy Splunk for a customer, a mid-sized customer, in a way that supported agile methodology. So this wasn't a big waterfall project where we did design for 2 months and then implementation. This had to be more iterative, and it needed to be under a complete, fully controlled route to live, meaning we needed a dev, a pre-production, and a production environment. We had to run identical configuration throughout in the vast majority of cases, which was really tough. And as we were not in any way experts in either DevOps or software development principles, for us as Splunk engineers and security guys, it was really interesting to get to know this technology and get to know how it could be tied together to work for our use case. So we chose a version control system, we chose GitLab, we chose a configuration management tool, we chose Ansible, and we tied that together to give us this full route to live. This led us to having a 99% identical configuration base, which we found really, really powerful. So I could literally pull down the master branch, which was in production. I could spin it up in my dev environment, and they would be identical. All the code, all the way down to the certs, would be the same. And we actually then built that within a Dockerized environment for dev, so I could run it on my laptop, and it would still be prod-like. And that turned out to be really cool and quite interesting for us. But again, it's not a deep dive, but I think something interesting to share. So when this was deployed out to the Security Operations Center, they'd used Splunk before, but this was introducing them to quite a lot of change. But over a period of weeks and months where we enabled and trained them, they realized that this empowered them to take risks. And that's, for me, one of the key points here, and the key takeaways is, if you encourage people within your system to experiment and fail, yet is safe, you get a lot more out of them. So rather than a SOC analyst sitting there processing alert after alert after alert, which is what many people do, then what you end up is with people that are willing to experiment. They're willing to, fork the branch, as it were, try something new, see if they can improve an alert, improve some onboarding, improve a dashboard, and they can do so in an instantly revertible state. No copying and pasting config out into Notepad to ensure that you can revert. It's all committed into your version control system. You have a huge commit history, which you can always roll back. And again, it was very empowering once they understood how it worked. So what this led to was they could make a change in their dev environment and promote it through to production in less than 5 minutes with the correct change and governance around it. So even though it was safe, it didn't mean it stopped them being able to hunt quickly and adapt to the threats that they were seeing in their environment. So I think we're close to finished. Rushed through that a little bit, but here's a few resources. These slides are uploaded to SlideShare, which we can put a link in the video for, so the links will actually work. Don't click on your screen, it's not going to do anything. But yeah, so there's some stuff about threat hunting, so it's a very well-defined framework. It's really powerful, highly recommend that. There's some interesting guidelines around building a SOC and building one with Splunk as well. SIEM, obviously enterprise security, and then there's some general tips for writing SIEM rules. And then finally, obviously, just in case none of you know what Splunk is, probably haven't understood much of what I've said, there's some great downloads for using Splunk and getting equipped with it nice and quickly. So thank you very much for listening, and I think that's everything I've got time for.